The year was 1973, and Don Lancaster, an electronics author and guru, had just dropped a device on an unsuspecting public that would change everything for the future of home computing, the TV typewriter. As I mentioned in a previous video, the TV typewriter was a revelation. Although it was a fairly humble device and not specifically aimed at computing, it nevertheless showed what was possible. Most importantly, it showed that home computing could be affordable. Others quickly took notice. One of those others was Daniel Meyer. His small but growing company, Southwest Technical Products of San Antonio, Texas, had been the contractor hired to produce the TV typewriter kitboards for Radio Electronics, the publisher of Don's article. Meyer had noticed the appeal of the new device, but he also noticed some of its drawbacks, namely how complicated it was to build, its reliance on obsolete or scarce parts, and the fact that, at the end of the day, it really wasn't intended to be what most of its builders hoped it would be, a home computer terminal. Meyer was in many ways a lot like Lancaster. He too was a skilled electronics engineer and designed projects that featured regularly in publications like Popular Electronics magazine, but Meyer combined those skills with a keen enthusiasm for business. In 1965, he founded his first company, Demco, the forerunner of what would become Southwest Technical Products. Over the years, his company established a reputation for quality, well-designed, easy-to-build electronics kits, mostly in the field of audio. But Meyer could see home computing on the horizon, and when the TV typewriter blew the doors open to an affordable digital future, Meyer wanted in. So Meyer turned to one of his young engineers, Ed Colle, and asked him to come up with an improved version of Don Lancaster's TVT. Colle had some prior experience designing terminals. He had designed the terminal for DataPoint in the early 1970s. At the time of Don Lancaster's TVT article, Colle had created a low-cost terminal to upload messages to digital signs. That company went bankrupt, and it was at its bankruptcy sale, according to Colle, that he met Meyer and was asked to design a new terminal for home use with a royalty payment of $5 for every unit sold. From the get-go, the CT-1024, also known as the TV Typewriter II, would be a considerably friendlier device to the hobbyist than Lancaster's design had been. The mainboard was larger than the original design, allowing everything to be spaced out more. This aided hobbyists in avoiding accidental solder bridges. The pads were reinforced to better withstand the abuse of inexperienced hobbyists and their soldering irons. The new terminal would use static RAM rather than shift registers, which meant that users could dynamically alter screen contents as they pleased. Static RAM had become much more affordable in the short time since the original TVT had debuted. The stock TVT-1 could only store 512 characters with a single page A memory board. The TVT-2 would be able to handle 1,024 characters out of the box, hence the last 4 digits of its official model number. This also meant the TVT-2 could provide a more capable cursor control system than the one Don Lancaster had devised. No longer chained to the timing of shift registers, the cursor could be moved most anywhere on screen the user wanted. The first 2 digits of the TVT-2's official model name, CT, stood for Computer Terminal. And this was important because from the get-go, the TVT-2 was intended to be a computer terminal rather than a proof of concept. Since the original TVT was only intended to literally typewrite on your TV, it had no interface with which to send and receive data from the outside world. That would come later as a result of the efforts of other hobbyists. The TVT-2, however, was available right out of the gate with a serial communications board that enabled the user data speeds of up to 300 baud. Like the TVT-1, the TVT-2 was expandable. Meyer had Colle design the TVT-2 to be modular so that Southwest could make money selling add-ons. Many problems confronted hobbyists trying to build the original TV typewriter. One particular problem was the lack of available keyboards. For the original TVT, hobbyists either had to attempt Lancaster's excruciating homebrew keyboard project or find a surplus unit they could modify to the right specification. However, the TVT-2 wouldn't have this problem. Right out of the gate, Southwest offered a keyboard called the KBD. It was based on a much improved hobbyist keyboard Don Lancaster had devised for a Popular Electronics article in 1975. This keyboard featured professionally manufactured key switches and a built-in ASCII encoder. It was relatively inexpensive, easy to build, and reasonably reliable. Support for the TVT-2 was also a fair bit better than the original. If you were building the original TVT and ran into trouble, your best hope was either a friend who was capable in electronics or a desperate letter to Don Lancaster, care of Radio Electronics magazine. Other than that, you were pretty much on your own. TVT-2 builders, on the other hand, if they weren't successful, could send in their incomplete or non-functioning terminals to Southwest, where Ed Colle himself would repair them at a cost of $25 each. The TVT-2, like its predecessor, was also published in Radio Electronics, electronics, making its debut as a project article in the February 1975 edition, although with considerably less fanfare. By the time the TVT-2 had arrived, there were already a few competing designs entering the field. Would-be TVT-2 builders were offered the unit in kit form, and most opted for that, but you could, using the plans printed in the article, build one entirely yourself if you so desired. The TVT-2 was soon joined by Southwest's 6800 microcomputer and became an almost inseparable component of that. But it was used by many people for a wide variety of systems and tasks, sometimes being paired with modems like the penny whistle to dial into other machines. It became Southwest's most profitable product at that point in time, being ultimately replaced by the CT-64, a 64-character variant. Although today the CT-1024 is mostly memorable to a select niche of collectors, historically it is important as another major step towards the home computer as an appliance, and I'm privileged to have 3 of them in my collection representing various iterations of the design. Let's check them out. Okay, so here are 2 of my 3 CT-1024s. I'm not going to bother showing the third as it's currently hooked up to one of my 6800 systems in a camera-unfriendly space, and really apart from the chassis, it's pretty much the same machine as the one on the left. The kit version of the CT-1024 was much more complete than the one offered for the original TV typewriter, which was really just boards. As well it should be, Southwest Technical Products was a company built on the electronics hobby. Southwest sold the basic CT-1024 kit for $175, minus the keyboard, chassis, and some add-on boards. A more complete kit was offered for $275 with pretty much everything you needed. $275 was more than twice the estimated cost to build the original TVT, but bear in mind this was including a keyboard, something the original TVT builders really had to hunt for. Southwest kits not only included the boards, but also all the parts required to build, including ICs, capacitors, resistors, and things like that. This was a huge advantage versus the original TVT, which left you on your own to find components. Another Southwest advantage was the documentation. I wouldn't call Don Lancaster's construction guide inadequate by any means, but Southwest being a professional kit builder meant their documentation was next level. In fact, I dare say their docs were the best, period, except maybe for Heathkit, whose documentation was legendary. This yellow Southwest binder came with a complete system I purchased from the daughter of its original owner. It came with a 6800 computer, AC30 cassette interface, and that third CT-1024 I was talking about. We won't concern ourselves with the 6800 documentation for this video. However, in the back here, the owner kept all the original documentation for their CT-1024, which is all the documentation I have on that. So this gives us a pretty good idea of what the kit builder got. Southwest typically sent the boards in boxes or padded envelopes. Then the parts were in little baggies in a Southwest marked box like this one. These are leftover bits and bobs from when the original owner of this 6800 built their machine. And as I mentioned earlier, Southwest, being a company devoted to hobbyists, offered a service to repair non-working CT-1024s and their components, with varying fees depending on what needed fixing. This was a boon for novice builders who knew enough to get most of the way there, but not quite all the way. The builder of this particular CT-1024 also collected documentation on improvements to the unit, including a modification to allow scrolling text. The manual contains the typical parts list. Like I said earlier, Southwest provided everything in their kits, including ICs, resistors, you name it. As I mentioned in my Unbuilt Kits video, kit makers usually had a parts list that they wanted you to go through to verify you had everything you needed before proceeding to build. Another important inclusion is the build instructions themselves. These detail the build order and testing procedures required as the kit build proceeded. These are quite useful today even. If you have a non-working unit, you can sometimes use these to trace back and figure out where the expected output or input isn't happening. These manuals also usually included a how it works or theory of operation section. These are particularly valuable for collectors since we can't go to the original company for help when things aren't working. They explain exactly how the system works, how each circuit interfaces with the other, and which ICs do what. Southwest's ace in the hole though for this kit was the KBD keyboard. Builders of the original TV typewriter had to do some serious scrounging or modifying to get a workable keyboard for their projects. Southwest, to its credit, saw the need for an inexpensive, general-purpose parallel ASCII keyboard. As I mentioned earlier, they developed and improved a design Don Lancaster had done for a popular electronics article. The KBD, as it was called, would go through several different revisions, mostly to improve the encoding, switch reliability, or to add function switches. This KBD5 represents the final iteration of this keyboard, and it features something most TVT builders wish they'd had, a backspace key. Southwest also moved a couple of control keys for the serial board directly onto the keyboard itself. The KBD cost about $35 as a complete kit. $35 was real money in 1975, the equivalent of about $170 today, but it was a heck of a lot less than the hundreds of dollars a commercial keyboard might run you back then. This made it really popular with hobbyists all over, not just Southwest kit builders. In fact, this keyboard has been spotted on occasion with original Apple I's, being one of the few keyboards of its kind available at that time. This makes it extremely collectible and pricey today. One of these today will set you back about $400 or $500. I never used to be a big collector of original documentation. Space is always at a premium, and most of these things are archived only for easy access. That said, lately I've come to appreciate the value of original documentation. It's a lot easier to fold open a large schematic than scroll around in Adobe Reader. And you get lots of insights sometimes, little handwritten notes that tell you what the builder was doing at any given time, problems they were working through, and so on. The builder of this system even kept a mini journal of sorts with dated entries detailing what was going on. On this page, the builder mentions learning certain parts of a kit piece he was working on were included in another kit. He also details some of his challenges with memory and serial boards, the latter being particularly tough to get working correctly. Stuff like this is like catnip for me. Quite honestly, I collect old machines not just to enjoy the machines themselves, but the stories of the human beings behind them. Having this fellow's original handwriting helps preserve this machine's human connection. Okay, so let's have a little tour of this kit-built CT-1024. One thing I will say about it is it has been finished to a higher degree than CT-1024s tended to be. I don't know what it is with mid-1970s computing, but a lot of builders chose function over form and often had the componentry completely exposed. The Southwest chassis offered for the CT-1024 was little more than a metal pan with a 90-degree bend at the back. I guess people weren't worrying about electric shock back then. This unit uses a home-built chassis made of plywood and is covered in what feels like grip tape. The builder also made a bezel or surround for the keyboard, upon which all the control switches are mounted. Most of the buttons are for cursor control, a major improvement from the original TVT. There's also a dial for what I suspect is baud rate control. However, like many a project, it appears to have never been, dialed in. This unit is fixed at the stock 110 baud. The keyboard bezel seems to have been designed to be easily removed and flipped over so the CT-1024 itself could be worked on. It was pretty common back then to have to take things apart from time to time and fix things or do modifications. Around the back, we have a metal plate for the power supply and something unusual for a CT-1024, a DB25 serial connector. Usually Southwest equipment use Molex connectors in a proprietary arrangement, so having this is nice and makes this terminal easier to interface with non-Southwest equipment. The main board of the CT-1024 was one of its key selling points. Everything is far more orderly and spread out than the original TVT design. And this was on purpose. It was to aid novice builders in avoiding accidental solder bridges. The main board still has an expansion bus using those awful Molex connectors. Ugh. I hate pulling the add-on boards off just because of that. But oh well. Hardware hackers apparently like them. The CT-1024, like the TVT before it, uses a Signetics 2513 character generator, which provides an all-uppercase alphabet as well as numbers and some symbols. The board also features a few trimmer resistors to adjust picture size, sync, and so on. The first board is the RAM board. It uses 6 2102 static RAM chips rather than shift registers for a total storage of 1024 characters. This is a major improvement over the original design. Because of the way the shift registers work, cursor control and character placement were somewhat limited. Static RAM meant things could be changed more or less at will on screen. Next up is the cursor board. Southwest actually sold a couple different versions of these. This version allowed manual control over the cursor via push-button switches. The other version, called the computer cursor control board, allowed for control via ASCII control characters, meaning the cursor could be manipulated by the computer you were using itself. This next board is a bit unusual. It's the screen read board. As the name implies, this board will basically read whatever is on screen and then output it somewhere. Thus, this board allowed the user to do offline editing or to transfer data to one computer from another by first downloading from one and then screen reading and uploading to the other. I've never had occasion to use it, but it's a neat feature, one of very few optional boards Southwest developed for this machine. At the very back here is the CTS serial board. I'm not going to pull it out as this unit is very fragile and those darned Molex pins have it in kind of a death grip. But you can see the basics. The UART is the big chip in the center, and then the rest of the ICs control baud rate and handle I/O to whatever you're connected to. This board is configured for 110 baud right now, but with modifications, one could adjust it for up to 600 baud, I think. Anyway, that's the kit build unit. This is the second CT-1024 we'll be showing on this video. The case is certainly different compared to the first one, and kind of bomb-proof. But that's not unusual. Not everyone used the chassis Southwest offered. The keyboard clearly isn't Southwest either, but again, you weren't obliged to use their unit. You could use pretty much any parallel ASCII keyboard you wanted. It's inside the case where things get a little different. This CT-1024 was built entirely from scratch by its owner, Tom Crawford. Tom did what you could do if you had the radio electronics article on the CT-1024. You could take the plans and its pages and etch the boards yourself. And that's exactly what Tom did, since the company he worked for had the equipment anyway, and it saved him a few bucks. And honestly, if you didn't know any better, you'd swear this was all Southwest kit in here. But on closer examination, you can tell this was a homebrew job, such as the untinned and now tarnished copper traces. Southwest by this point in time was tinning their boards. Tinning puts on a protective coating that gave the copper traces a silvery finish. Homebrew PCB makers typically didn't bother doing this. Another mark of homebrewishness is the use of solder con sockets. I mentioned these in my previous video on unbuilt kit computers. They were socket pins that came on a roll. You broke off as many as you needed for each side of your socket, soldered them in, and then broke the metal tab up top to separate them. The CT-1024, unlike the original TVT, used double-sided board. The holes, or vias, on factory-produced double-sided boards have a metal sleeve inside that connects one side to the other. This isn't something a homebrew maker can easily furnish on their own, and so it was necessary to solder components on both sides to make the necessary electrical connections. If you were really skilled, you could pull this off with plastic dip sockets, but SolderCon being all metal made it a whole lot easier. Vias that weren't occupied by components simply required a short piece of wire. You can imagine how difficult it would be to get all these hundreds of holes to line up correctly on both sides of the board. I certainly can. I've been working on a Mark 8 mini computer replica build, and as I can attest, making double-sided boards yourself is a real chore, and I've had the benefit of modern tools to help me, like Photoshop. My hat is definitely off to anyone like Tom who could do the job back in the day without all those aids. Tom Crawford was no casual hobbyist though. He's an engineer who knows his way around a soldering iron, as his handiwork shows. Tom was a founding member of the Association of Computer Experimenters, an Ontario, Canada-based group of hobbyists that had a particular interest in the RCA 1802 CPU and the Cosmac ELF. They developed a range of upgrades for the Netronics ELF-2 that eventually became its own computer, the ACE. Tom edited the group's newsletter, ipso facto. Tom told me that he built this machine to use as a dial-up terminal, I think to work or university, I can't recall which. You've already seen a photo of it in the introduction, actually. That's a shot of it in operation in 1980. Note the Lee Felsenstein designed penny whistle modem to the left. Tom used soup cans for the acoustic couplers the phone handset was placed on. Tom did a really impressive job with this machine. I think he could fire a 50 cal at the case and it would probably bounce right off. In fact, if World War III starts, that's where I'm going to be hiding. Everything inside is neatly laid out in a way I could personally never manage. I love all the vintage Dymo labels that explain what's what. Tom even employed his engineering skills in shipping the unit to me. The thing arrived so expertly packed, all strapped down with foam and melamine boards, that I think you could have tossed it off the back of a cargo plane with no parachute and it would have been just fine. It took me literally an hour to fully unpack the thing. Now, apart from the homebrew factor, this CT-1024 is mostly the same as my kit version. However, Tom did tweak a few things. First, you'll notice this extra board in front of the main RAM board. This is an upgrade that Tom thinks was used to provide 64 character output rather than the normal 32 character output. I believe it also enables this CT-1024 to do something my others can't, scrolling. In that sense, Tom's CT-1024 operates more like a real terminal. The keyboard, Tom said, probably came from an electronics surplus store somewhere in Ontario. I don't know exactly who made it, but based on the key labelings, I'm guessing it was probably used with terminals or teletypes of some kind. It's a million times better to type on than the Southwest KBD, and far more reliable. Tom also gave it a lot of ribbon cable to connect to the CT-1024. Like, a lot. I guess he wanted to be able to type from a neighboring house or something? Otherwise, Tom pretty much followed the standard CT-1024 design. There's the cursor control switches above the keyboard, which I've labeled with a modern labeler for my own reference. At the back, we have a couple of coax-type video outputs, baud control switch, horizontal sync control, and a huge power supply heatsink. Over on the left, we have the actual power switch and two always live plugs for whatever else you needed power for, maybe a modem or a TV. Anyway, this system still works after all these years. So that's enough touring. Let's fire these two bad boys up and see how they work. Okay, so here's our paint by numbers CT-1024, so-called because it's basically built entirely from the Southwest kit parts, apart from the chassis, which I mentioned before. Basically, it's pretty much exactly the way any builder would build it. The one difference with this guy is he did a nice little bezel around the keyboard, and he's got all the control switches up here. You've basically got your power switch, you've got your baud rate control, which actually doesn't work because it was never hooked up. You've got control over the receiver, which is basically the serial board. You can turn it on or off. You've got an echo. Local echo is handy when you're just typing by yourself, because if you don't have a computer to echo things back to you, then you're not going to see anything. But obviously you turn that off when you're communicating with the computer because it's echoing back whatever you're typing. This switch here is the memory page switch. So you can switch between page 1 or 2. I think on the old TV typewriter it was called page A or page B. And it works basically the same way. You just switch from editing on one memory page to editing on the other memory page. And then this is the cursor on or off button. If you wanted a blinking cursor, you could have it. If not, you could turn it off. These buttons here control basically cursor positioning. And this is sort of the signature feature of the CT-1024 compared to the original TV typewriter. You actually have some direct control over cursor movement. And I'll show those off in a second. And then the last button here is the screen reader. Now the screen reader is that little card I showed you. Basically what you can do is you can work with this thing offline and create a page or two of text. And then when you're connected to whatever you would be connecting to, say your work or school computer, you could actually hit the screen read button and it would basically read everything off out to serial and to the remote machine. So it gives you a little bit of an offline editing capability, although obviously with only 1,024 characters available, not that much. Now, looking at the motherboard of the CT-1024 here, there is one thing that may not be immediately obvious, and that is that despite the name TV Typewriter II, there is no RF modulator. So there is no direct interface with a television set. The only way you could do that is if you either modified your television set to accept a composite signal, or if you came up with an RF modulator of your own. And this is important because when the TV typewriter originally came out, that was one of the big selling points was, hey, you've got a TV in your house, why not use it as a computer terminal? But by this time, which is only a couple years later, people were able to get composite monitors fairly cheaply at this point. They could pick up a surplus security monitor, a black and white thing for not very much money. So it was much less of an issue as far as the affordability of the overall unit. And I think a lot of people were cluing into the inconvenience of using a television set as your primary monitor anyway. Another reason Southwest may have left out the RF modulator is just simply that it adds to the complexity of the kit. And plus, if a lot of people weren't going to use it anyway, then they didn't want to have to supply the parts for it. So it was just easier to offer that as a separate option to people. I don't know if Southwest offered an RF modulator of their own, but I know there were other companies that did. So yeah. Visually, there's really no difference between this and the original TV typewriter because, as I said, it uses the exact same character generator, the Signetics 2513. Now, let's say we wanted to bring the cursor up to the top and clear everything like we did on the original TV typewriter. We hit the home button and then we hit erase to end of frame. And that basically will delete everything after the cursor all the way down. So that's basically your first page of memory clear. If we want to go and look at the other one, that's the other page of memory and you can see it's full of stuff here. And again, the cursor's already home, so I can just hit end of frame. Now I've got two clean pages of memory to do with whatever I want. So at this point, as long as the echo is on, I can just start typing. I can do now you'll notice I'm typing pretty hard. This keyboard, I don't know if this is just the way it is or if it's my rebuilding job didn't go quite as well as I'd hoped, but you really have to press hard to get anything on screen. Some of the keys are better than others. So I've just typed out a line here. You can see I've made a mistake. This is the area where the CT-1024 really shines over the original TV typewriter because on this machine we have direct cursor control. Now on the original TV typewriter you could absolutely go back and fix a single character, but comparing the way it did things and the way this one does things is a little bit like comparing a car with a manual transmission to one with an automatic transmission. On the TV typewriter, the original TV typewriter, basically what you had to do first was you had to switch the cursor into reverse. And then the next thing you had to do was enable keep mode. And that was to ensure that it didn't delete anything as you type backwards because you have no arrow keys with the original TV typewriter. You only have your typewriter keys and you have to use one of them. It doesn't matter which, but you basically have to type your way backwards. So as long as it's in keep mode, it's not going to change or delete anything. And typically you would just, hit the space bar or whatever, or whatever key you wanted, just to make the cursor go backwards. When you'd gotten to the place where you wanted to go, then you had to switch the thing into change mode, and then you had to switch the cursor into forward mode and then type what you wanted to type to fix the error. And then you had to switch into keep mode again and then type your way back. So it was a bit involved, and it wasn't an insurmountable technological obstacle. It was just that Don was trying to keep the design as basic as possible in order to keep the cost down. However, by the time this machine came out 2 years later, things were getting a lot cheaper, so it was more feasible to put in proper cursor control. This machine has what's called the manual cursor control, so basically you use push buttons to determine where things are going. And in fact, the owner of this machine actually rigged up the keyboard with a couple of the blank keys that Southwest allowed you to use as arrow keys. So fixing my mistake is as easy as doing that and then doing that. That's a heck of a lot easier than doing it on the original TV typewriter. I found the original TV typewriter process to be incredibly frustrating. And yeah, like I said, if I wanted to keep notes or something on the other page here, I could just do, you know, oops. Switch to page 1 and switch to page 2. Pretty simple. Now you'll notice one thing that is still absent on the TV Typewriter II, there's no backspace key, and that's just the way it is. You could do backspacing if you were connected to a computer system. There are control keys that allow you to do that. I'm trying to remember off the top of my head which one it was, but it's not coming to me right now. And yeah, the backspace key did not come out until the 5th and final revision of this keyboard, the KBD5. I'm not really sure if it was fully implemented or not. I meant to check that. And I can tell you that it does work. The other TV typewriter I have in my back office, you can actually hit the backspace key and it will go back and delete whatever is there, just like a normal computer. Another thing to get used to with these is when you hit return, the cursor goes back to the beginning of the line, but it does not go down. So it's actually a two-step operation. You do return and then you have to do line feed to get to the next line. That's just the paradigm that they were working with back then from teletype days, I guess. I think my other TV typewriter in the back office, you can actually hit return and it will automatically do a line feed. But on this one, obviously it doesn't. The keyboard is, I mean, it's not bad. The spacebar on this needs a bit of work, again. You know, it has a pleasing kind of clicky sound to it. Again, this was a hobbyist keyboard. It wasn't designed as a commercial product for business use. So I've actually got one out from my other TV typewriter that I've been trying to understand and make it work. Just open it up here. They're pretty amateurish in terms of build quality. You basically got your plunger here, and then there would be a little spring in the middle that pushes that back up. You've got a couple of contacts in the bottom there, and then there's a little piece of, it's like model railroader's wire. And basically when the plunger is pushed down, it makes contact with that little wire between the two contacts, and that's basically how it registers that a key has been pressed. It's about as basic a system as you can get, but it's a little bit unreliable. It's definitely not as good as like a Cherry MX switch, not even close. But again, this was being aimed at hobbyists. It was not being aimed at business clients. It was not built to the same standard. So it just provided you with something that was workable. And I've actually been working on trying to replicate these key switches. There were a couple of different versions. The ones that are in this machine are not exactly like these. They're a bit even more primitive than these are, which is why they're so tricky to use. But yeah, I actually got my hands on an original copy of the construction guide from Don Lancaster's original Popular Electronics article, and it has the PCB artwork for the keyboard in it. So if I can figure out a way to basically make these switch bodies and then make the keycaps, then in theory I could potentially start reproducing these keyboards. And I might do that because that'd be something I think that's useful to a lot of hobbyists. who are doing retro projects, it's hard to find a keyboard that is suitable to this era, 1975, 1977 or so. Now the screen read on this one doesn't seem to work. I don't know if there's a key sequence that's been rigged up for it. I've tried using different control keys to make it work, but it doesn't seem to do anything. All the other switches pretty much work except for the baud control, which I already mentioned. The cursor switch here, basically you just switch this off and it does nothing. Okay, there we go. So the switch is a little bit finicky, but you can see if I switch this off, then it stops blinking and then it just becomes a solid cursor, which some people back in the day preferred. I don't know that it really would have mattered to me, but that's what it is. Okay, so what we've got here is basically the kind of setup you might have seen in the mid-70s. This is an original Southwest 6800 computer system from about, I think this one was actually built around 1977 or so. This is pretty much the typical setup you might have seen back then. The only thing we're missing are the cassette decks and the AC30 cassette interface that goes between those and the computer. But we're not going to be doing that today, number one, because I can't really fit it on camera, and number two, because it's all hooked up in the back office and I'm just not messing with it. So although I'm trying to keep this fairly period correct, we are going to break with that a little bit. First of all, instead of using the Southwest's own original serial communication boards, we're actually going to be using one made by a company called Corsham Technologies. And the reason I've chosen to use that one is because it has a DB9 connector on it, which makes it a lot easier to swap cables. And the reason we're going to be swapping cables is because we're going to be using this machine, a ThinkPad 380XD, to actually load programs to the 6800 that we can then display on the CT-1024. And this laptop is kind of my favorite go-between for vintage computer equipment. It kind of has a bit of everything. It has a floppy drive, it has a CD-ROM, it has PCMCIA slots on the side, so you could add it to your network if you wanted to. It's got audio, and it's got serial port on the back, a native serial port. And then last but not least, it has a USB port, which was a brand new thing at the time this machine came out. So that makes this machine a really good bridge in between all my vintage machines to do various things like test communications with old computers like this to see if they're working under more ideal conditions before switching over to using vintage terminal equipment. But yeah, because I don't have the tape decks out, I'm basically going to use this to upload a text file that contains the same information that a tape would have, and that's going to load the program onto the 6800. And then I'm going to swap the cable over to the CT-1024 so that we can actually use a real Southwest terminal with this machine to get a sense of what it feels like to operate at 110 baud. And I think by the end of that experience, you'll probably be like, yep, I'm pretty glad that we got away from there. So yeah, so the first thing we will do is we will set up the 380 here, and we'll use Hyper Terminal basically to transfer everything from one machine to the other. Okay, so we got the 380XD up and running here, and the first part of this process to load a program into the 6800 so that we can then display it on the CT-1024 is we need to open up Hyper Terminal. And I've already created a profile for this that fits this machine perfectly. SWTPC 110. We're going to be operating at 110 baud here, unfortunately, because that's what the kit build CT-1024 is permanently wired to. Otherwise, I would obviously do this at a much higher baud rate. So it's going to suck a little bit, but that's all we can do. So we've got our terminal set up here, and we will turn the 6800 on. And there's our little $ prompt. And then basically, you know, if I wanted to just edit memory contents and stuff, obviously I could do that. I just sometimes do that just to make sure the machine's actually properly responsive. But what we want to do here is put it into load mode with L, and then we're going to use transfer and send text file. I've actually got the program that I want to use. It's called Klingon by TSC, as I mentioned, and it's basically just a clone of Star Trek, which was a really popular game during this era. And then that's basically it. We just sort of wait. Now, I do have something on the back of the machine called a breakout box. I'll get into more detail on that a bit later when I'm working with my other machine where I'll really need it. But basically, I can see that there's data going into the machine, because one of the things with this process is it's basically kind of silent. So the computer could be downloading the information happily, or it could be completely crashed. But basically, if I can see data going in and otherwise everything looks okay, then I just have to take it on faith that it's working. This load process will take about 25 to 30 minutes, so obviously we're not going to film all of that. I'm going to spare you that detail of authenticity. The file itself, let me just see if I can get to it here. Just so you know how long it takes to transfer a relatively small amount of information. There's the Klingon notepad file, and it is 10 kilobytes. So it's going to take 24 minutes to download 10 kilobytes to this machine. So there's a lot of computing enthusiasts from the 1970s who lost quite a few hours of their lives waiting for stuff like this to happen. But we won't do that here. We will come back as soon as this is done. By the way, that kind of hammering kind of noise that you're hearing in the background there is actually a little 5-volt USB fan that I've rigged up to one of the light stands just to cool the power supply, because this 6800, I haven't figured out exactly where, but it really starts to overheat after a while, and then it starts doing unpredictable things. And I found keeping air on it is a good idea. I guess Southwest didn't think it was necessary to have a fan, because the case top is basically just an open mesh. But a lot of these machines that have come up on places like eBay, they actually have third-party fans installed, because these things can get quite hot. Okay, so it looks like it loaded successfully. I will just issue the G command to start it. Yeah, and there it is on the laptop. So now what I'm going to do is I'm going to swap cables over to the CT-1024, and then we can experience life as it was in around 1975, 1976. Okay, so I've got the terminal up and running, the program is running. You can see I've switched the cables there at the back. I kind of had to, the port on the back of the CT-1024 is a DB25, and the cable I was using was just 9-pin at both ends, so I had to switch that out. I may have to employ my breakout box again to cross over the RX and TX, because I think this relies on a straight through, but we'll see what happens. We'll just hit enter here. Okay, so nothing's going through yet, so I have to put in the breakout box, cross the signals over, and then we should be good to go. Okay, and you can see it actually just did it itself. It prompted up for the password. I'm not sure what this password is. I think it's a really early form of copy protection, so I might think the game might malfunction. They might have the Klingons turned up to 100 or whatever. I don't know what the password is. I could probably get the manual, but we're just going in here for demonstration purposes. And I'd better shut the echo off, because that's going to cause problems. Date is 7941, Klingons 58. And what's my command? Well, let's have a look around the galaxy here. I'm just going to erase to end of frame. Yeah, so you gotta be kind of patient to play this at 110 baud, because yeah, it takes a little while to draw everything. All right, well, there's our star map. You know, I was never a big Star Trek fan, and I never really played this game much as a kid. My entry into home computing was with the Commodores, so I was used to graphics and stuff, and this just seemed incredibly boring. Let's see what commands we have here. Scan for Q1 to Q7. And again, I'm going to do the end of frame thing here, just so we can keep the screen fairly clean. So I guess that's where the Klingons are somewhere. And then 3 is energy available, 3,000. I don't know. I don't feel like putting too much in. I'm a pretty low energy kind of guy. Misfire. Oh, I didn't know warp engines could misfire, but okay. Let's try 4. Course. I don't know, where do you want to go? 45? Nope. Out of energy. Okay, well, that makes that pretty definitive. Let's see what other commands are right here. 5. Dev stat. About 7. I can't do 6 because that key is broken, unfortunately. Oh, shields down. Okay, I really hope I have the shields up here somewhere. Too early. Okay. How about 9? What does 9 do? Password. Oh, well, we don't have that. All. No. Sequence abort. Password. But yeah, that gives you a pretty good idea, I guess, of kind of what it's like to play a game at this speed. It's kind of cool to look at. Like I definitely like the blinky, slow kind of. I definitely kind of like the look of it, like just the blinky, slow, one character at a time type deal. But yeah, it's. It's not really a great thing to play on. It would be so much better if it could actually scroll. Scrolling would be a massive advantage. Okay, so see okay, so that is working. So basically if I have the page switch in the middle position here, you can actually have it switch between the different pages of memory. I'll just clear that rest of that frame. Well, isn't that interesting? So this machine actually does do what my other TV typewriter does. So if you have it on page 1, it only uses page 1. If you have it on page 2, it only uses page 2. But if you have it in the middle, it will dynamically switch between them. Let's just test that out a little further, see if it'll switch back to page 1 or not. I think it did it. It kind of tricked me there. I'll probably have to look at it on the camera to be sure. Let me just erase to end of frame. We'll just keep scanning the cosmos here because I really want to see if it'll switch over again. I mean, this is how it would have come across on a teletype. I would have found the teletype more interesting, though, to be honest. There's something magic about analog communications over distance. Yeah, no, it's definitely changing pages. And you can see the screen bounces every now and again. I think the horizontal sync is just slightly off. So that's good that it switches pages, but the only thing that sucks is it doesn't actually clear things as it's going, right? It only types out what it needs, and if there happens to be something after it, it just leaves it there and moves to the next line. It's kind of a pain that you gotta keep hitting erase to end of frame in order to get a nice clear screen, but at least you've got 2 pages to work with. And you could, and I mean, if you really wanted to get fancy, you could leave this as basically your scan of the universe here, and then switch over to page 2 and use that as your combat panel. And then if I wanted to refer back to my star map, I could just do that. So, there's it's kind of like the 1975 equivalent of a cheat code. Close enough. But yeah, that's the operation of this thing in a nutshell. There's nothing more I can really show you here that, it's basically, this is what it is. It is a very, very basic home terminal from 1975. So what we'll do now is I will shut this down and we will switch over to the other CT-1024 that I have, the one that is completely homebrew, and that'll give us a chance to see a slightly different implementation of it with 64 characters, which may or may not be advantageous in a situation like this where they're expecting 32, but also much faster speed. That machine, I know I can adjust the baud rate on it, and I believe I can run it at about 1200 baud, so 10 times faster than this. Never thought I would ever be looking forward to 1200 baud again, but I definitely am right now. Okay, so here is the Crawford TV typewriter, which I'm just gonna call it that in honor of its builder. So yeah, it's a pretty nice little unit. It's all metal construction, which is obviously quite durable. I've always had trust issues with homebrew machines that are all metal construction because I'm always afraid that the builder makes a mistake or something happens in transit and you end up with live AC grounding to the case, and then, you know, that would hurt. Thankfully, that's not the case. Tom did a great job building this, and I haven't been electrocuted even once yet, except when I accidentally touched the terminal strip at the back. I touched the AC side of that, and that was not pleasant. The keyboard, like I said, it's pretty nice, and definitely better to type on than the Southwest unit. Obviously, this was a professional keyboard that was designed for some sort of commercial purpose, so you would kind of expect that. You've got some notes here on the left. These explain the control functions, which I'll show a little bit later. And then across the top here, you've got my labels, because I was trying to figure out which switch did what. And the only switch I couldn't figure out was this one. This one seems to disable output for some reason, I think. This is the receiver, so that turns the serial board on and off. This also turns off the transmit out function, so I don't know why there's two of them there that do that. And then we have the echo, so you have a local echo. You can, you know, test and see if it's working, or if you want to work offline, you can do that as well. And then you have the two memory page switches, which I haven't quite figured out the operation of yet. It seems like when they're in certain positions, the terminal will either do scrolling or it will just do the standard, hits the bottom of the page and then goes straight up to the top and starts from there again. Not really sure how that works or if that's even working properly. It's always a thing with 40-year-old equipment. It may not be working properly. Then we have the cursor button, which just turns the cursor on and off to sort of blink or not blink. On this one, it's more like a twist than a blink, so you'll see that. And then we have the screen read enable, which basically enables that board to read the entire screen contents and then fire that off out through the serial connection. So yeah, nice keyboard, nice response, nice and clicky. Like I said, not really sure why we have 1.5 miles of cable, but I'm sure there's a reason for it. Okay, so we got our screen of junk here. And this is sort of like what the other TV typewriter does. So what we want to do is we want to clear it, and I have to make sure for some reason the echo button is on to do that. Now, unlike the other TV typewriter that relied on push buttons to do certain functions like homing the cursor, clearing to end of frame, this one doesn't. It's actually all by control key. So if I hit Control L, that brings the cursor to the top left. If I hit Control Z, that clears the screen. And then I can just start typing. And that's basically it. And if I want to move the cursor around, I can actually do Control I moves it that way, J moves it down, H moves it this way. So if I made a mistake, I can actually just hit Control and then H and go back to my mistake, and then hit Control I. So pretty much like the other CT-1024, just using control keys instead of push buttons. Yeah, it's just a whole lot easier when you can just move the cursor around the screen and just, you know, go wherever you want. Just makes a whole lot more sense. Now, the other thing that this one does is scrolling. Now, right now, it's in a mode where it's just gonna go over and over and over the same page, just like the original TV typewriter does, and just like my other CT-1024 does. But if I change one of these switches here, and yeah, basically just keeps going up like that. You know, a little thing, but still something that is profoundly useful because it gives you a chance to read back whatever is sort of in the history of your session there. So, and it just looks more natural. You know, it kind of sucks when everything's stuck on one screen and the cursor hits here and then it starts overwriting up there. It's not really ideal. Yeah, I mean, it doesn't have a ton of memory to work with. Obviously, we've got twice the amount of memory that the original TV typewriter had, but we've got twice the number of characters, so we can only really store one page at a time here. But, you know, that's a small trade-off. Another thing you'll notice we have a speaker. And it actually has the bell key, and he's actually set it up so that the bell key does something. It's Control G. If you've been around vintage computers, you've probably seen that bell key on a few occasions and wondered what it was, especially on the Apple II. Basically, it's a holdover from teletype days where you could alert the remote operator, whoever you were talking to on the teletype, that you needed them for something. You would just hit Control G and they would be like, okay, I'm coming. And that was it. I don't really know what the purpose of this is with a computer system. I guess maybe it sends some kind of alert through to somebody at the other end, potentially. Maybe if you're doing terminal-to-terminal communications with somebody, that would be one possible use, but that's a thing. And then this is the cursor here, if you really want it. It's kind of, I don't know, it's kind of blinky. It's, yeah, kind of twisty. I don't even know how to describe that. It just blinks so fast that the system kind of has trouble showing it. It's like a super fast blink. And that's off. And that's on. And interestingly, when I turn it on, the video starts to get a little bit unstable. And then of course we can hook her up to our 6800 here. Now for this demonstration, I'm basically going to employ the exact same trick that I used on the other CT-1024, but on that one I had a DB25 port that I could plug into. I knew it was wired correctly, so all I had to do was physically change cables and that would work. On this one, there was a DB25 port on the back. There's cutouts for DB25s, I think. But there's no actual port there anymore. There's basically 4 or 5 wires hanging out in that vicinity. I only need 3 of them. I need a ground, I need RX and TX. And I have to figure out which of those wires is what. So a handy thing to have when you're trying to do that is this thing called a breakout box. And it's not really much of a box, but basically you plug it in line with whatever device that you're trying to troubleshoot. And it has a series of dip switches like this. And basically what you can do is turn each pin on or off. And you can actually do things like reroute one pin to a different pin. And this is where it's handy because not every machine is wired the same way for serial output. Some work just fine with a null modem cable. Others expect a straight through serial cable. So this is a convenient way to just sort of flip back and forth rather than changing cables and driving yourself mad that way. And the other thing that it gives you is a series of indicator lights. And that gives you a visual on what's actually happening. So you can actually see, you know, is the computer trying to send any data? Is the terminal trying to send any data? Are they conflicting with each other? That sort of thing makes this really, really handy. Okay, so I got everything set up here and I ran into a few little problems. The first one was basically the terminal, whenever it was receiving things, it would basically bring in garbage on the screen. So when I had the 6800 in and it was sending down information, I could see it coming in, I could see the little $ prompt that it has, I could type stuff in, it understood me, but whatever it fed back had all kinds of nonsense with it, which kind of made for poor viewing. And I spent quite a while thinking about this and wondering what was broken in here before remembering that the serial cards on these things have jumpers that basically configure parity. And you know, it's been a long time since I've had to worry about parity, so I wasn't even thinking about that. And of course I discovered looking at the card and comparing it to the one in my other TV T2 that there were 2 jumpers configured for parity differently than what it was in the other one. The other one didn't have any plugged in at all. So I removed those, that got rid of the parity settings, and then that started working just fine. Okay, so now what I'll do is I'll fire up our vintage 6800 system by Southwest again, and we will see what TSC Klingon, the Star Trek clone, looks like with scrolling and 64 characters. And fire that up. And there's our prompt. I can start, oops, I'll turn off the echo. I can start looking through memory contents. I can start changing memory contents. Man, I love that 1200 baud. It's so much better than 110. Wow. 110 is just brutal. I don't know how people could stand that. Yeah, I'm just throwing random stuff here, but yeah, obviously in this mode, it's going right back to the top of the screen and then overwriting everything, which is not really what we love, but it is what it is. And then if I switch the mode, now it's scrolling up. And yeah, that's kind of more what you're used to when you're working with a computer. Just stuff scrolls away and disappears, and yeah. Obviously it sucks because you can't go back, but again, that's a limitation of the amount of RAM that the terminal has. Obviously, if you were technically inclined, you could probably add more memory and get more buffer if you needed it, but hey, this is a major improvement from the original TV typewriter, for sure. Going the other way would have driven me absolutely crazy. And I'll just do a couple things to clear the screen first. Control L, Control Z. Okay, then we turn the receiver on. There's our screen. And we'll just hit G. And we'll just do short game. And they want a password, which I don't know the answer to. Supernova and Q5. Sure. And yeah, I mean, that's better. That's definitely better than it was on the other one. It's nice having smaller text and faster, smoother stuff going on here. All right, so that's it for the Crawford TV typewriter, and that's kind of it for our video. In terms of future plans for this, basically, I'm probably going to take it apart again and try and figure out why it's wigging out when it gets hot. Just try to dial it in a little bit better, and then put it back up with this 6800, and then I have a nice, fast, scrolling terminal that I can use with it when I really want to do actual work with that machine. So yeah, that's it for this video. Hope you enjoyed it, and thanks so much for watching, and we will see you in the next one.